Hello and welcome to a new episode of All Things IDA. So far we have covered enough IDAPython functionality, we've covered a bit of IDA, and I think it's about time to talk about how to write our first plugin in IDAPython. So we'll cover, as usual, what makes a plugin by looking at the SDK, explaining some concepts, and then we're going to write our first simple Hello World plugin, and of course deploy it, test it, and so on. All right, as usual, so to get started, plugins and the concept of plugins, the best information we can get started with is from the loader.hpp file. In the loader.hpp, this file has structures that lets us define plugins, processor, and loader. But for now, let's focus on the plugin. So plugin, the first thing is we need to look at plugin underscore t. This structure is what we are responsible to export from our, if we're writing native, from our DLL or SO, dylib, or in IDAPython we will have a global symbol name, as we shall see, to achieve the same effect basically. So what is a plugin underscore t? So the first thing is, as a structure, it should contain enough information describing the plugin alongside callbacks of the plugin, initialization, termination, plugin flags, what IDA version has been used, and so on. So the first field is version, and we should always put IDP interface version. This simply resolves to the current SDK version. So if we're gonna compile as a native plugin, then that number will be encoded into the binary. So a future version of IDA can do some compatibility checks. So version, as you'll notice in Python, we don't touch it. We don't even populate it. Flags are the plugin flags. These are important flags, and the names are self-explanatory with respect to draw, seg. With respect to unload, this is very interesting. That lets us do quick development. This is the trick that I used for IDAQ scripts to let you test native plugins quickly. We'll talk about different techniques for prototyping in Python. So I would say this is not necessarily super useful for Python. We will discuss in future episodes best strategies to quickly test plugin code. But that would be useful for native development mainly. Plugin hide, this will make our plugin invisible in the menu. So when we install a plugin by default, in IDA in the plugins folder, our plugin will show here by default. Unless, of course, we specify our plugin flags to have plugin hide. Plugin debug is not supported in IDAPython yet, but this will let us write a debugger plugin. If we look at who uses it, for example, here we have in the debug folder, these are some of the source code of debuggers. And since this is a common file to most of the debuggers that come with the SDK, we notice that that flag is used. So we specify don't show us in the menu, and we're gonna be a debugger. Plugin proc. This is just tells IDA how soon to load our plugin. So load our plugin when a processor module is loaded and keep it until the processor module is unloaded. Plugin fix. This one lets us load the plugin as soon as possible. So when IDA starts, before many other subsystems are loaded, this gives us the chance to load, even if there's no database open, no processor module active, no file loader, and so on. This flag, for example, is used by IDAPython. If we go to the IDAPython sources, we will see IDAPython hides itself, and it's fixed to basically load as soon as possible without a database. The multi-flag is used to specify that we're using a modern plugin methodology. This flag is recent. It did not exist before. You will still see lots of plugins on the internet not even aware of that flag. So IDA still keeps backwards compatibility and lets you have plugins without that flag. But if you want to be future-proof, we will be using this flag going forward. We're not gonna be using obsolete stuff or legacy and so on. So this flag we have to pass going forward. And this will also change the way our plugin is structured. I will mention if we omit it, what happens, and if we use it, what happens. But again, we want to keep our plugin future-proof and stay away from obsolete methodologies. This is an internal flag we shouldn't really be using. Okay, so these are the flags so far. Again, don't worry about like how and when to use them. Once we have something tangible, everything will click. After we have the flags, we have some callbacks. And that's when I was talking about legacy plugins or obsolete methodology. So the first thing is for a plugin, we might want to have an initialization callback. And back in the days, the initialization callback used to return a number, which used to be like skip, I don't want to be loaded, or it's fine to load me and keep me in memory. But if we specify multi, designating a new kind of plugin, the modern plugins, then the init callback is responsible for returning a new instance of our plugin module. So the plugin underscore T is kind of like a descriptor containing flags, callbacks, description text, hotkey, and so on. And the plugin itself, which will have the actual functionality, should be implemented in a subclass of plug mode T, which we will visit in a second. So the plugin descriptor should also describe an initialization routine, returning an instance of our plugin. Now, if our plugin doesn't want to be initialized or doesn't want to be loaded for certain conditions, then it will return a null instance. And by returning a null instance, it is similar to returning plugin skip in legacy older plugin systems. So far we are the no obsolete functions is defined when IDAPython is built. So those constants might still be available to you, but again, whenever I'm doing episodes in the future and so on, I will do my best to avoid anything marked as obsolete. So since we're talking about modern plugins, we still have two callbacks. Termination, what happens when our plugin terminates, and what happens when our plugin is invoked. For a modern plugin, the run and terminate have been delegated to the plugin module. So when we initialize and return a new subclass of plug mode, we would have overwritten the run and a destructor for that plugin module that simulates a termination event. Legacy plugins, we had to specify two extra callbacks. Init would have returned a number. Terminate would be invoked on termination. Run will be invoked when the plugin is run through the menu here, when we pick it from the menu. But those will not be used in modern plugins. Instead, we'll look at using those callbacks differently inside a subclass of plug mode. Again, this is native so far, so it doesn't map 100% one-to-one in IDAPython, but I would like to explain it to give you the full picture. Because definitely most of the concepts carry over, the syntax will change. Then we have command text that is associated with our plugin. So if we go to the plugin and we navigate over a plugin, we'll see the plugin name, which basically maps to the wanted name. We might see a hotkey, which maps to the hotkey. And we have here the description, which also maps to the description in the status bar here. So to recap real quick, we have to export a plugin, a symbol called plugin. of type plugin T, fill in the fields appropriately, proper flags, proper callbacks. Callbacks should behave in a certain manner, and so on. Now, here, this is basically the global symbol that we should be providing. So this is just like a forward declaration, so to say, or an extern. But then we as plugin writers have to declare that variable. And then it will be marked as exported, or you export it manually through your compiler or linker flags. Okay, now let's look at plug mode. So you need to return an instance for your plugin. What's a plug mode? Plugin module as well is a class. Now in native, we will notice it has some helper methods and so on, but these are just helper methods, meaning they're not really part of what you have to override. You might want to use those helpers, maybe not. So we can safely ignore event listeners for now and just focus on the most basic thing. So when you subclass plug mode, you have to override at the minimum this virtual method run. And the run method is responsible for handling the execution of your plugin. Now the run argument, you might be wondering, where does the argument value come from? So if we go to the menu and select any of those and click, the run method will be invoked. But when the run method is invoked, arg will have a default value of 0. So we can tell if 0 is passed, we can assume that it's being invoked from the menu. Now we can always specify any run argument and programmatically invoke a plugin. So let me see where that method is. Load. All right, let me find it. Should be back in loader. Load and run plugin. So we have a method that can let us programmatically load and run the plugin. Load part is interesting because if we have IDA running already and then we drop a plugin after the fact, we don't have to restart IDA necessarily. So all we have to do is simply drop the plugin appropriately, install it appropriately, and then simply load and run it. And we specify the name of the plugin, just the name without the extension, and we can specify the arg. So this is one way to programmatically run and load the load and run the plugin. If it was loaded already, it will simply run the run method, and you get to control the argument. There are other ways to control the argument value, and we will see later it's in plugins.cfg where we can also configure multiple entries per plugin. So we can have the same plugin with different label, and per the configuration we can pass another argument value. So that's for the run methods. And so what was the equivalent of terminate methods on the plugin itself is in the plug mode destructor. So if we want to really deinitialize, we simply have our own destructor, and that's it. So modern plugins got rid of those two callbacks. We should not put anything. Those callbacks are gone. We just have to make sure init returns. If it wants to work with the database, it should return an instance. Okay, so now we're ready to jump into our first IDAPython plugin. So if you have the SDK, you should have a sample plugin called hello.py or py-hello, and the plugins and the SDK plugins hello. This is the minimal plugin basically. So let's see now how what I explained earlier maps. So by convention, IDA kernel will look for this special symbol, plugin entry. This is equivalent to exporting a plugin symbol. So let me show you a plugin binary. So I'm going to go to the IDA plugins binary folder and pick any plugin. And you'll notice any plugin, no matter which one we pick, and even if we are on a different operating system, If you dump the binaries exports and see what symbols it exports, we should see that at the minimum, it should export a name called plugin. And that plugin is really of an instance of the data structure plugin T. So if we're reverse engineering a plugin, we can simply jump to the plugin export symbol and apply a plugin T structure on top of it, and we should be able to see the callbacks and trace them, enter into the init method, see the plug mode, and so on and so on. So back to the plugin Python version. Instead of exporting a large symbol called a single symbol called plugin, conventionally we export or have a global symbol function basically called plugin entry, and IDA kernel will invoke it. When it's invoked, we are gonna return a plugin T. That's the same descriptor we discussed. So in scripting in IDAPython, we have to write that function and return an instance of plugin T. Since we're returning the same plugin T we discussed, so we have the same fields, so flags, for example. Here it is specifying unload is not necessary, but it's gonna behave the same as a native plugin. It will load and unload, giving a chance to for IDA to reinterpret it each time we invoke it and so on. But again, there are better strategies for quick prototyping of Python plugins. So this is fine for now. We don't need it. Comments, well, we saw comments still map to the same stuff. So comments, wanted name, wanted hotkey are the same stuff. So flags, minimal flag is plugin multi. So this is a modern plugin. Then if we don't specify multi, okay, if we don't specify multi, then our init should return plugin skip, plugin OK, plugin keep, one of those. For example, we still then have to have run, and this we do whatever we want in run. And we have to specify a terminate callback. We have to. So this is important for legacy plugins. But if we say plugin multi, now I would like to draw your attention to something important. Next version of IDA, whatever it is after 8.2 SP1, then these will be no longer needed. So you don't have to put empty methods. So for now, I'm gonna ignore them. I will notice that the init method does indeed return an instance of plug mod or some instance of a subclass of plug mod. So the same way as in the native, init returns something inheriting an instance of a plugin module instance. So now from plugin T, now we're ready to define our plugin logic, which should be sitting in a subclass of plugin module underscore T. What happens to our terminate? Now, we don't have a destructor, but if we had a Python destructor, then this is really acting like that the plugin is unloaded or being terminated. So a plugin has to have a global function called plugin entry, returns a plugin T where we describe our plugin. Flags are important. Description. If you want a hotkey, you can put it, or if not, you just keep it empty. The wanted name is just a friendly name in the menu. It's gonna show here. And the comment in the status bar. Then init will have logic here. It will decide to check the environment, check the database, the input file. If you recall from a previous episode where we used the IDA global info, we could have checked for For example, if IDA API dot get inf file type, and we can check, for example, if it's only the PE file, then we return an instance, or it will return none. So it's gonna return none if we don't return explicitly anything. So like this, we specify that our plugin will not initialize unless the input file is PE file, for example. Then if we're okay, we have to return plug mode. Plug mode, here we go, it's the subclass. You can have a chance as well to initialize yourself. So you can have your own initialize as well, and so on. Or here, so up to you. But then you have to define a run, taking the argument. Let's also display the argument. And then here we handle the destruction when the plugin no longer wants to work. Now, what about deploying our plugin? First thing is, there are multiple locations where we can deploy our plugin. Right now, the file I modified is still sitting in the SDK, so IDA is not aware of it. I took a copy of IDA into the bin, into the SDK bin. I took a copy from wherever I installed IDA, I put it here. Plugins. This is one location we can deploy the plugin. So if I simply paste my plugin file here, it will be picked up. So let me edit it just to give it something distinguishing name. So here it would say hello Python plugin, looks good. That should be visible enough. All right, so just copy it to the plugins folder, and let's run IDA. Now make sure you run the proper IDA. Since I installed it directly in the plugins folder next to the IDA, then you have to run the proper IDA. Later, if you install the plugin in your profile directory, then it will be picked by any IDA executable, not necessarily from the local plugins next to the IDA executable. All right, so look at this. We got the message, plugin loaded. If I go here, this is from the init, and it was happy as well because of the input file type was a PE file. This is a PE file that we loaded. Now let's see if it will show in the plugins menu. Since we did not specify plugin hide, it should show. So edit plugin, and our plugin should read hello Python plugin. So here it is with the hotkey Alt F8, and this is the plugin. Now when we invoke it, since we return the plugin mode as we described, once I invoke it, it should call run, and since it's invoked from the menu, it should be arg0. So now there's a hotkey for us to achieve the same list of the plugins. Instead of every time going to the menu and selecting, notice here we have quick run plugins. We have, if you press Ctrl+3, we get a chooser with all the plugins that we have seen in the menu. So I like to use Ctrl+3, it's faster, and I can search if I want. So I will filter for Python, for example, and that's my plugin. If I run it, here we go, hello world, arg equal 0. Now let us test load and run. So the plugin name here is py hello. And because it is py hello, that's enough. We don't have to specify the extension. So if I say IDAPython.load and run plugin and type just py hello and pass arguments. So I'm going to pass 1, 2, 3 and enter. Now notice what we got. We did indeed invoke the run method but we return 0. Basically, run would return true or false, or the equivalent of a true or false. So here we did actually receive the argument, the callback, the run callback got it correctly, and the plugin returned false. All right, let's see if our delete or destructor or terminate will be invoked when the database closes. I'm gonna close the database and don't save. And here we go. We see plugin terminated. So I mentioned that we can deploy the plugin in different locations. So not only we can paste the plugin just in the plugins folder wherever we installed IDA, we can also put it in our profile directory. To get the profile directory, let's say you're running on Mac, Linux, or Windows, doesn't matter. If you're not sure where is the profile directory, simply invoke IDAPI.getUser IDA directory, and it will tell you where it is. So in this case, it's in the app data roaming hex raise IDA Pro. If we go there, it might be an empty folder, like nothing's there, maybe just a bunch of files and so on. If we create a plugins folder, if it wasn't there, and then I'm gonna move this plugin from this IDA that is a copy in the SDK, put it in the profile directory. So here, just move it. Now, if I run my IDA in a different folder, so I have two copies of IDAs, one I put for the SDK and one in my tools directory. Whichever IDA I invoke, it should basically pick up the database. So here, this is the different IDA, and that's the plugin. And it's not explicitly in the SDK IDA, but still, if I invoke the SDK IDA as well, it should also show here. So that's one way to deploy a plugin globally for all IDAs for your user profile. Now, if multiple users use IDA, but different user profiles, and in my case, I installed my IDA in my own profile directory, so everything I do is gonna be only showing for me, for my user. But most people install IDA in C program files. So if you want a global plugin, you would have to install it in the program file so any user can see it. And if you then want a local copy of it, then per user, you go to your profile directory and deploy the plugin. So really, you can have global plugins. If IDA is installed in a global folder, you put it there. And local to you, you put a plugins folder inside your IDA user directory. So get user IDA dir. Go to that folder. If you don't have a plugin folder, make it and install your plugins here. Last thing before we finish is just a quick troubleshooting technique to tell why our plugin is not showing or if there's an error and so on. Open the help file and go to the command line switches. And here we have the -z flag. This is an important flag. You can run IDA with that flag and specify the 20 value. So 20, or you can OR it with any other flag value here in the debug flags. But I want only plugin module diagnostic or debug messages. So I'm gonna pass -z20. If you want other subsystem to display the debug, just OR those flags. So let's see what happens when we run IDA with -z20. So I'm gonna go to the command prompt and go to the IDA folder. I'm gonna say IDA -z20. And I don't have to directly open the database, you can pass, but what's important is simply you have to pass -z20. Let's close this IDA and run a fresh one. So it does have -z20. The moment we open IDA, we should start to see diagnostic messages. So let's open the database and see what happens. So IDA loaded, IDA then as well will reveal how it actually scans and what it scans for. So it will say, all right, I'm gonna be looking for plugins, and I'm gonna look for start.dll, IDC plugins, Python plugins in your user profile directory first. And then I'm gonna look for wherever IDA is installed. And then for each plugin, I'm gonna ask it if it wants to initialize and what it replies. And it will remember the answers based on what's the flag of the plugin. The plugin might say directly that it wants to be kept the first time it's loaded. Some plugins would say just like the regular multi-flag. It will tell IDA, you can load me, but for now, since the user doesn't need me, unload me until the user goes back to the menu and invokes the plugin. So IDA will do like initial scan, take account of the plugins, read the plugin underscore T, get the description, hotkey, so it knows how to populate the menu and so on and so on. And based on the flags, some plugins will be unloaded, then loaded only when they needed to be invoked. So here we can see what's happening, every plugin that's loading, what they answered, and so on. And here, if it's a plugin that is non-native, so script plugin, we also have like some other debug messages, like specific to Python, internal objects, and so on. And IDA will differentiate. It knows it's a script plugin. And so here I edited closed multiple times. Let's see what happens if we invoke a plugin, for example. So as well, when we invoke, we can see the message. Let's invoke one more time. Same story. If I close, you see what debug messages we should get as well. So as well, we get to see the order of the initialization. So these were the last two times I invoked the plugin. Every plugin is being unloaded. Here, it's time for our Python plugin. The destructor is picked up and it's called, and so on and so on. So this is a very useful flag, basically, the -z20. So I hope you found this introductory episode useful for writing IDAPython plugins, and you understand how plugins work under the hood. Thank you, and see you next time.